Welcome back to Security for Legal SaaS. I'm Alice.
And I'm Dan. Episode 9, Cross-Site Scripting, or XSS. Alice, last episode we talked about injecting into databases. This time, the injection target is the user's browser.
Exactly. SQL injection attacks your server. XSS attacks your users. The attacker injects malicious JavaScript into pages that other users view, and that script executes with full access to whatever the victim can see. In legal SaaS, that means session tokens, privileged documents, client communications, anything displayed in the browser.
How does malicious script get into a page in the first place?
3 variants. Stored XSS. The attacker's script is saved in your database. Maybe it's in a case note, a user profile, a comment field. Every user who views that record executes the script. Reflected XSS. The script is in a URL parameter that the server echoes back in response. The attacker sends a crafted link to the victim. And DOM-based XSS. DOM stands for Document Object Model, the browser's internal representation of the page. The server is never involved. Client-side JavaScript reads from an unsafe source like the URL hash and injects it into the page directly.
Right. In legal SaaS, stored XSS seems particularly dangerous. You have shared matter notes, collaborative documents.
Catastrophically so. Imagine a case note field that doesn't encode output. An attacker, or a compromised account, saves a script tag as a note. That script sends the session cookie to an external server. Every lawyer, paralegal, and partner who opens that matter gets their session stolen. The attacker now has authenticated access to every matter each of those users can access.
Right. And because it's stored, it keeps executing every time someone views it. It's not a one-shot attack.
It persists until someone notices and removes it. The SAML worm in 2005 demonstrated this can go viral, an XSS payload that copies itself into every profile that views it. In a legal SaaS context, a worm in matter notes could propagate across every case a lawyer touches.
Terrifying. Okay, what's the primary defense?
Context-aware output encoding. The principle is simple. When you render user-supplied data into an HTML page, encode it so the browser treats it as data, not code. But the critical nuance is that different contexts require different encoding. User data in an HTML body needs HTML entity encoding. Angle brackets become &-LT and &GT. User data in a JavaScript string needs JavaScript escaping. User data in a URL parameter needs % encoding. Get the context wrong, and the encoding doesn't protect you.
Modern frameworks like React handle this automatically, right?
They do. Auto-escaping means the framework automatically converts special characters like angle brackets into their safe HTML equivalents, so the browser displays them as text rather than interpreting them as code. That's eliminated the majority of XSS and greenfield apps. React's JSX treats all interpolated expressions as text by default. You can't accidentally render HTML. But, and this is a big but, every framework has escape hatches. React has dangerously set and skull, Vue has vhatch-null, Angular has bypass security trust channel. These exist because legitimate use cases require rendering HTML, rich text editors, formatted content, document previews. Every use of those escape hatches is a potential XSS vector.
Yeah, legal SaaS has a lot of rich text, matter notes, contract annotations, legal memos with formatting.
Which is exactly why legal tech has elevated XSS risk compared to, say, a calculator app. You need bold, italic, lists, headings, maybe tables. The safe approach is to sanitize with an allow list. DOM Purify is the industry standard. It's maintained by Cure53, a security research firm, and it's been hardened against hundreds of bypass techniques. You define exactly which HTML tags and attributes are permitted, and everything else is stripped.
What about document previews? PDFs, Word documents displayed in the browser?
Massive attack surface. A PDF can contain JavaScript. An HTML email rendered in your app context can include script tags. a docx with embedded macros. The key defense is origin isolation. You render untrusted document content in a sandboxed iframe, an iframe being an embedded web page window inside your page. On a different origin, preview legalapp.com, not app. Legalapp.com. The same origin policy, the browser's built-in rule that prevents one website from reading data belonging to a different website. Block scripts in that iframe from accessing your main application's cookies, DOM, or APIs. Alternatively, convert documents to images for preview. That eliminates active content entirely.
Now, content security policy, CSP. I hear this mentioned constantly in the context of XSS.
CSP is a browser-enforced policy that restricts what resources a page can load and execute. The most important directive for XSCs is script sampling. If you set it to self without unz inline and without unz eval, the browser will refuse to execute any inline script, even if an attacker successfully injects one into your HTML. The injected script tag is there in the DOM, but the browser says, nope, CSP doesn't allow inline scripts and blocks execution.
That sounds like a complete defense. What's the catch?
Two catches. First, you have to actually eliminate inline scripts from your own code, which can be a significant refactoring effort for legacy applications. Second, Google research from 2016 found that 94% of deployed CSPs were bypassable, primarily because developers added unseen line to make their existing code work, which defeats the entire purpose. A CSP with unsafe inline provides almost no XSS protection.
Right, so it's only effective if you commit to the refactoring.
Correct. The migration path is move all inline scripts to external files, then use nonces, random tokens generated per request that must match between the CSP header and script tags. Only scripts with the correct nonce execute. Attackers can't predict the nonce, so injected scripts are blocked. Deploy in report-only mode first, so you can identify violations without breaking functionality.
What about the href attribute? I've seen XSS through links.
JavaScript pseudo URLs. If user input ends up in an href attribute, like a source link on a shared document, and the user supplies JavaScript alert 1, clicking the link executes JavaScript. Auto-escaping frameworks don't prevent this because it's a valid href value syntactically. You need explicit URL scheme validation. Only allow HTTP, HTTPS, and mailto. Block JavaScript, data, and VB script, schemes unconditionally.
Let me summarize the legal SaaS specific risks: rich text editors, document previews, email rendering, and any feature that displays user-controlled HTML.
Plus collaborative features. If one user can inject content that another user views, shared matter notes, annotation layers, comments, that's a stored XSS surface. Every collaborative feature in your application needs output encoding or sanitization on the rendering path.
The defense stack then is auto-escaping framework as baseline, DOM purify for rich text, CSP to prevent inline script execution, sandboxed iframes for document previews, HTTP only cookies, cookies marked so JavaScript cannot read them, so even successful XSS can't steal session tokens directly, and URL scheme validation on all href attributes.
Exactly. Layers. No single control is sufficient. Auto-escaping has gaps. CSP can be misconfigured. DOM Purify has had bypasses. Rare, but they've happened. The combination makes exploitation require bypassing multiple independent controls simultaneously.
Next episode, file upload security. Users upload documents constantly in legal tech. PDFs, Word files, scanned images. What happens when those files aren't what they claim to be?
Until then, I'm Alice.
And I am Dan.
Security for Legal SaaS is a series written with AI assistants. Alice and Dan are AI-generated voices. No professional advice here, just education.